Alright, welcome to section 1.1 part 2. Alright, where we're going to look at the properties of addition and multiplication. So you can see I've set up a little table here, and I'd like you to do the same thing in your notebook. Alright, putting the properties in the left-hand column, leaving a spot for addition problems in the right column. Get this little dot here. And then some spots for the multiplication. Alright, that's in the right-hand column. So the first property we're going to look at is the commutative property. And the commutative property, the word commutative comes from the word commute. And that you should be familiar with because a lot of people use the word commute to refer to their travel to work or to school. So I want you to think about the route that you took to school today, or that you normally take to school. Okay, so you leave your house, you get to school, and now take the exact same route home from school to home. If you take the exact same route both ways, you will travel the exact same distance. Alright, and that's the idea of the commutative property. It doesn't matter if you're going from point A to point B, or from point B to point A, it's the same end number. And we can see that with addition. So we're going to use the variables A and B here. So we've got A plus, oops, let me get the green color in here. So we've got A plus B is equal to B plus A. Doesn't matter which comes first. If A comes first or if B comes first, they should equal the same thing. And to prove this, we're going to assign numbers to the variables. So let's say A holds the value of 5 and B holds the value of 2. So 5 plus 2 should equal 2 plus 5. And we can see it does, because 5 plus 2 is 7. 2 plus 5 is 7. It's the same. So we've just proven that the order that the numbers come in when you're using just addition, alright, you'll always get the same answer. Same holds true for multiplication. Instead of A plus B, we're going to have A times B is equal to B times A. If we have all multiplication, does not matter what order the numbers come in. Right? So let's see if this is true. We'll use the same values of A and B. So we'll say A is 5. B is 2, so 5 times 2 should be equal to 2 times 5. And we can see that's true, because 5 times 2 is 10. 2 times 5 is 10. So we've just proven that the commutative property of multiplication is true as well. So let's go down to the associative property. Associative property comes from the term associate. Alright, so it doesn't matter how you associate different terms or different variables or numbers, you should get the same answer as long as you have all addition or all multiplication. So to make numbers associate with each other, variables, we're going to use grouping symbols, parentheses. Alright, so we've got A plus B plus C. Alright, so A plus B plus C, and we're going to group A and B together here. Let's see if that holds true if we say A plus B plus C, and if we group B and C together. Alright, it should be true, but we'll test it by applying numbers to the variables. So we'll still say A holds the value of 5, B holds a value of 2, and we'll assign C a value of 3. So we've got 5 plus 2 plus 3. And we'll plug in those values over here. So 5 plus 2 plus 3. Now remember, when you have grouping symbols, you got to think back to your PEMDAS, your order of operations. You have to do parentheses first. Alright, so we want to make sure we evaluate these parentheses. 5 plus 2 is 7. Drop down my 3. And then I've got to evaluate these guys first in parentheses. So 2 plus 3 is 5. So I drop down this 5. 2 plus 3 is 5. 7 plus 3 is 10. 5 plus 5 is 10. We can see it's the same. Alright, so it doesn't matter how you associate or group numbers, alright, it should be the same as long as you're using all addition. It will be the same. Same holds true with multiplication. If you're using all multiplication, you can group numbers any way you want. So we can see that if we group A and B together, it's going to be the same thing as grouping B and C, just as we did here, just with multiplication. So let's test it out with the same numbers. So instead of A, we're going to say 5 times 2 times 3 is equal to 5 times the quantity 2 times 3. And just as we did before, make sure we evaluate parentheses first. So 5 times 2 is 10 times 3. And then 2 times 3 is 6. So 10 times 3 is 30. 5 times 6 is 30. It's the same. So if you have all the multiplication or all addition, doesn't matter how you group your numbers. Let's move down to the identity property. We'll get 3 more. Identity, inverse, and then we'll end with the distributive property. So identity, all right, think about identity means what? It means who you are. All right, you can't change who you are. All right, maybe you can change your personality and things like that, but you can't change your DNA, you can't change your fingerprints, you can't change your dental. All right, those are markings of who you are. All right, so there's no way to hide it. So if you have an identity problem, all right, you should always end up with the same answer. All right, so let's say we're working with some variable a. We have the addition problem, so we're going to add something to a to still end up with a. We don't want to change a's identity. We want to end up with the same variable or the same number. Well, what's the only thing you can add to a number to keep it the same? That's 0. So you can have a plus 0 or 0 plus a. That's still going to give you a. Doesn't matter the order it comes in. That kind of goes back to the idea of the commutative property up above. So what was the value of a? All along it's been 5. So let's say 5 plus 0. What is it? Still 5. You don't want to change the identity, don't want to change the value of that number. So the only thing you can add to it is 0. What about multiplication? Let's say we've got a, want to multiply it by something, and we still want to end up with a. If I put in 0 there, a times 0, well, anything multiplied by 0 is what? 0. So we can't use 0 here. So in order to end up with the same value, what do you multiply by? Well, that's 1. So a times 1 is a, or 1 times a is a. So plugging in 5 for a, we can see 5 times 1 still gives us 5. So if you ever end up with this exact same number, you know that's the identity property. You're not changing its identity. Okay, lastly is inverse. All right, inverse is either the opposite or the reciprocal. All right, when you're dealing with addition, all right, think about the term inverse as being opposite, an opposite sign. All right, with multiplication, inverse is going to mean the reciprocal. It means you flip the fraction. Whatever's in the denominator goes in the numerator. Whatever's in the numerator goes in the denominator. And we will see that. So we're going to start out, we'll just use a here. All right, so let's say a, and now we want to add its inverse. Well, its inverse is going to carry the opposite sign. So it's going to be the opposite of a. Well, if you add a to the opposite of a, you're going to end up with 0. Right, so let's use our value of a. It's always been 5. So 5 plus the opposite of 5 is going to give us 0. So when you're using the inverse with addition, you're always going to end up with 0. All right, the inverse for multiplication, if we've got a, we're going to multiply it by its reciprocal. What's the reciprocal of a? Well, that's 1 over a, right? Because what's the denominator here? The denominator is 1. So if I flip this, the denominator becomes the numerator, numerator becomes the denominator. There's my reciprocal. So if you multiply anything by its reciprocal, you're going to end up getting 1. See the connection here? 1 through multiplication, zeros with addition. So let's try our number 5. 5 times, what's the reciprocal of 5? Yep, that's 1/5. That equals 1. Okay, last one, distributive property. All right, I'm going to draw a little line here. All right. Distributive property, I drew that line because it's not just addition and then we're going to look at multiplication. Distributive property holds addition and multiplication together. Alright, so I'm going to put a little note here. It's both addition, and multiplication. So it's going to have grouping symbols in it, similar like just as the associative property does, but don't get distributive property mixed up with the associative property. Associative property is going to have either all addition or either all multiplication. Distributive is going to have addition and multiplication in it. So what's the formula? It's going to be some number A times the quantity B plus C. And what you're going to do is you're going to distribute this A and multiply A times B. So it's going to become A times B. And then that A is going to get multiplied by C, and that's going to get added to A times C. So this A gets applied to both the B and the C, and you can see that here. So let's use our numbers 5, 2, and 3. Alright, so we've got 5 times 2 plus 3 is equal to 5 times 2 plus 5 times 3. Let's see if it's going to be the same. So I'm going to evaluate the left side. Well, we know grouping symbols. So 5 times 5. And then we know 5 times 5 is 25. And then here we've got 5 times 2. Oh, that's 10. Plus 5 times 3. That's 15. What's 10 plus 15? 25. So we see an example of the distributive property here, and it's exactly the same answer. Alright, so those are your properties.